Hello everyone, welcome back to my channel Learning Fundamentals by Ankit Shukla. I hope you're all doing well. This is the part 2 of the chapter 2 for the networking fundamental series. In this session, we are going to cover the IP subnets and subnet mask, different types of networking devices like routers, modem, switch and many more. If you haven't watched the chapter 1 of the session, please go to the description of the session below or subscribe to this channel and check the session 1 of the series. Let's get started with the session. That's the end of the classes of the IP addresses. We'll now move on to the IP subnet and subnet mask. A simple definition of subnet is logical subdivision of an IP network. It allows a large network to be divided into smaller, more manageable networks. Subnetting helps in improving the network performance, security, and efficiency by segmenting traffic and isolating the network issues. On the other hand, subnet mask, it's a 32-bit number. It is often represented in dotted decimal notations like 255.255.255.0. It is used to divide an IP address into network and host portion. It defines the boundary between the network part and the host part of the IP address. The subnet mask uses 1 bits to represent the network portion of the IP address and 0 bits to represent the host portion. As you can see in this diagram, we'll go a little deeper into the subnet and subnet mask. Imagine yourself, you are in a vast city with numerous neighborhoods, right? Each neighborhood or a community has a specific number of houses. Each house has a unique address, right? Let's think of IP network as the city, the neighborhood of that specific region within your city as the subnet, and the houses represent the individual IP addresses. Now, talking about subnetting for this. A subnet would be, in this classical example, would be like dividing the city into smaller neighborhoods. Each neighborhood can contain a specific number of houses, which means the subnets. This division helps in managing and organizing the network more efficiently. For instance, instead of having one large unmanageable city, you break it down into smaller neighborhoods or communities or regions that are easier to handle and control. On the other hand, subnet mask is like a map that tells you which part of the address is for the neighborhood or a specific subnet and which part is for the individual house. It's like having a guide that explains which part of the address identifies the neighborhood and which part identifies the specific house within that neighborhood. Here's how it works. If you see this diagram, the IP address 192.168.1.10, it represents, or think of this as an address of a house in a specific neighborhood. Okay. The subnet mask for this is 255.255.255.0, right? This subnet mask basically determines how much of the IP address is used to identify the neighborhood and how much is used for the house. Now, because this is a class C IP address, as I explained in the previous section, the first three represent the network, the last one represents the host. So in this case, the subnet mask is 255.255.255.0. The first three parts represent the IP address of the neighborhood, or you can say the subnet mask. The last part represents the house, right? Now, see the diagram very carefully in the bottom section. You see 192.168.1.0 is divided into two parts. First, the network portion, that is 192.168.1, and the host portion, which is .10. It's represented in the green color if you look at the bottom. The subnet mask indicates that the first three octets are used for the network. The last octet is used for the host. This entire division helps in managing and organizing the IP addresses within the subnet, just like dividing a city into neighborhoods and houses. We'll now move on to the networking devices. Networking devices are hardware components which are used to establish, manage, and optimize communications between different devices on a network. Let's see that through a common example that we have in day-to-day life. First, we have internet, then we have a modem, we have a router, then it is split into a switch and an access point, and we have different devices which are connected through wired or wireless medium. In this diagram, internet represents the global network that connects different various networks worldwide. Modem, the next one in the list, is something that converts the digital data it receives from the internet into a format which can be usable by your local network. Router, on the next one, is router. It directs the data packet received from modem, or you can say from internet to your local network via a modem, of course. It also helps in the built-in firewall for security. So basically a router works as a firewall for security purpose. Next we have switch. The purpose of switch is that it connects multiple wired devices like PCs, printers, and servers. If you look at that on the left hand side, access point on the right hand side, it connects different wireless devices to the router instead of a wired network, just like what a switch is doing. Now, an explanation of this diagram clearly tells you how you access the internet through a wired or a wireless medium, through a switch if you're connected by a wired, through a access point if you're connected to the internet, or your router via a wireless medium. Next we have router as the first network device. The function of the router is that it directs data packets between different networks, such as between your home and the internet. There are different examples over here. I'm absolutely sure you all have experienced them, used them in your day-to-day life. The one that shows up at the bottom, it's like an industrial router, which is used by the organizations for a bigger purpose because they have bigger range or a larger range. They need to connect multiple devices or more devices that you can assume which are not available in a home network. You can imagine router as a traffic cop for your internet traffic. It's a device that connects different networks together, like your home network to the internet. Router decides the best path for data to travel from one network to another. It ensures that it reaches its destination efficiently. Now we have switch. Imagine you are at a party wherein everyone is talking and doing chit chat. In this scenario, a networking switch is like uh, it's like the party organizer who helps the people communicate efficiently. Um, just like a party organizer ensures that the people who want to chat with each other get connected. That's the job of a switch. A switch connects different devices within a network, but instead of connecting people, it connects computers, printers, and other devices. Then we have hub as the next networking device. Imagine you are at a party again with a lot of guests. Now picture a networking hub as the loudspeaker that we have in parties. So the loudspeaker basically it broadcasts the message to everyone because everyone can hear it, right? So a networking hub basically sends data to all the devices connected to it within the network. It's broadcasting everything, whatever information it is getting, it is broadcasting that to all the devices which are connected to the hub. That's the work of a hub. Next one we have is a modem. Imagine you're sending a letter to a friend who lives very far away. Let's say I'm in Delhi I need to send a letter to my friend who is in US. You write your letter in a language your friend understands, right? But the letter needs to travel through various postal systems, right? Through customs, through flights, the transportation, and from different formats and rules, right? So basically, that's the job of a modem. Modem is like a post office worker who handles the complex task of converting and sending your letter through different postal systems so that it reaches your friend in a readable format, right? It's like modulation and demodulation. Let's say when you talk to your friend over a phone, right? You speak, that is converted to signals. The device that converts that signal to the recipient on the other end of the phone who hears that, that's a modem. That's called as modulation and demodulation to be precise. Next in our list of network devices is the access point. Imagine you are at a busy convention center with multiple rooms and hallways, right? You want to stay connected with your friends throughout the building. An access point in the convention center would be like a series of information desks strategically placed around the venue to help you stay connected. Imagine you are in a shopping mall. I'm sure you all have visited once. If you go to a shopping mall, there probably be a dedicated network available to you within the hall in the entire shopping mall itself. If you understand it correctly, even if you're on the ground floor, you have the same signal strength. When you move to the first floor, you still have the same signal strength from the same network you are connected to. What's basically happening is initially when you came into the shopping mall, you got connected to the network. Then once you walk certain meters or certain distance away from the initial device that you were connected to, it automatically connects to the next device, which is in the same network. That's the job of access point. In modern days, access points can be used as repeaters as well. Basically, repeaters is the next level of access points. So, and you get connected to different routers, but within the same network, providing the same signal strength. That's the job of an access point. Next in our list is a very important topic. It is about the firewall. Firewall is, and again, one of the network devices. It is like having a security team at your event. It controls and monitors the flow of information between your network and the outside world, making sure only the authorized and safe data gets through. Whether it is incoming or outgoing, firewall scans that. There are four jobs of a firewall. It filters the traffic. It applies the rules and policies that you choose to. It monitors and logs the incoming and outgoing traffic. It also helps you prevent unauthorized access. Next, in the list of networking devices, we have a bridge. In networking, a bridge connection, it's like two or more network segment. It joins two or more network segments, allowing them to communicate as if they were a single unified network. Just like a physical bridge connects two land masses to different areas, a network bridge connects two different segments of network. This could involve linking different LANs or connecting parts of networks that use different technologies. It filters and forwards data between these segments, learns about the devices on managing traffic and extending network reachability. Just as a bridge connects physical spaces, a network bridge connects digital spaces, ensuring smooth and efficient communication across the network. In this diagram, you can clearly see there are two hubs which are connected to bridge. So these two hubs have two different segments of network. This bridge is connecting these two hubs, and hence The hub on the left hand side can read the information about a device that's on the right hand side connected to the different hub. And similarly, other devices can be handshaked or information could be shared. Using this bridge, it connects the two hubs. All right, next, and you can say the last topic for today. It is the most important topic. This is a network gateway. Now imagine yourself, you are at a large international airport wherein different countries have their own customs and security procedures. To travel between these countries, you need to go through a custom checkpoint, security checkpoints, and all that. That ensures, that is there basically to meet the entry requirements for you, and that your travel documents are in order, like your passport, your visa, or your work permit, or your travel document. At this place, the customs checkpoint that works like a gateway. It acts as an entry point and the exit point between different networks. After converting the data formats or protocol, ensure smooth communication happens between the systems that use different set of technologies. How does a network gateway works? Just like a customs checkpoint connects travelers to different countries, a gateway connects networks that use different protocols or technologies. For example, it might connect a private network to the internet or link two different types of networks such as the corporate network and a cloud service. You might need to adjust your documents sometimes because of regulations at the securities or the customs when you go to a destination country, and properly processed by the destination network. Who does that? The network gateway. It has security and access control. Then, in short, if you have to say or summarize, a gateway is like a customs checkpoint at an international airport, facilitating communications between networks that use different protocols or technologies. It connects these networks, converts data formats or the protocol that is needed, and then it routes the traffic and often provides security controls as well. By serving as an intermediary, like, you can say somebody saving or safeguarding your data when the data is going outside the network. It ensures that the information flows smoothly, securely between different systems and making the network communications more seamless and effective. Well, this is the end of our chapter 2, the networking fundamentals, guys. Thank you so much for tuning in. I hope you find this video helpful and informative. If you have enjoyed it, don't forget to give it a thumbs up and hit that subscribe button to stay updated with all the latest content. Also, feel free to leave a comment below. I would love to hear your thoughts or answer any questions you might have. And if you have any suggestions for future videos, just let me know. Thanks again for watching. I'll see you in the next video.